where we'll be looking at a final example on factor theorem, on what factor theorem actually entails. So in this question, this particular question is a very nice one. Why? Because you have a different type of approach that we actually take to this one. Now, in this one, you are given a polynomial where you have a particular variable, an unknown variable, aside the original x that we have. You are given another unknown variable q, and then you're asked to actually manipulate around this and then get whatever you're asked to get. So I just want you to understand that in this, the approach to doing this is a very delicate one. You need to take your time to actually analyze it, and then before you now start up whatever you are going to do. So just follow me through as we go through this, and you will understand the concept very explicitly. Now, looking at this example, we have the polynomial x cubed plus 4x squared plus 7x plus q, where q is a constant, is denoted by f of x. Now, Roman figure 1. Given that x plus 2 is a factor of f of x, find the value of q. Roman figure 2. Express f of x as a product of a linear factor and a quadratic factor. Now, the first information we have taken from this is that we are given a polynomial which has another variable, that is, in fact, the variable is a constant. It's supposed to be a particular whole number that will just be at the end there, but it's not the whole number, it is now q. So they're asking us that the polynomial is f of x. They're now asking us to find the value of q if that polynomial has a factor of x plus 2. That means x plus 2 is one of its factors. So what do? They're giving you a factor and we're looking for q. What you need to do is apply factor theorem. So applying factor theorem, so we are given that the polynomial f of x is given as x cubed plus 4x squared plus 7x plus q, where q is a constant. Fine. Then we are given x plus 2 as a factor. We are told to find the value of q. Now, to find q, now from factor theorem, we remember that I will equate my factor to 0, and then x, we have been told that is a factor, so we just equate it to 0, and then whatever value we get, we substitute it into the original polynomial. So the polynomial here was x cubed, so it becomes x cubed plus 4x squared plus 7x plus q equals to 0, of which we have gotten our x here from factor theorem to be minus 2. So substituting minus 2, so where x equals to minus 2, this will become minus 2 cubed plus 4 into minus 2 squared plus 7 into minus 2 plus q equals to 0. So simplifying this, I get minus 8 plus 4 into 4 minus 14 plus q equals to 0. I can get my q here because this is a linear equation. I have minus 8. 4 times 4 here gives me 16. Minus 14 plus q equals to 0. I know this is 16 minus 8 here is 8. 8 minus 14 is minus 6. So I have q minus 6 equals to 0. From here, I've gotten my q. So therefore, my q is 6. Now I've gotten the value of q, but that is my Roman figure 1. But my Roman figure 2 is actually telling me to express my function, my polynomial, as a product of a linear factor and the quadratic factor. What am I supposed to do in this case? So I remember how the polynomial was with a q. So since I've gotten q, since q now is 6, then I can say my f of x, then f of x is now equals to x cubed plus 4x squared plus 7x plus q, where our q is now 6. So this will now become the new polynomial. That is, we have gotten a value of q, and we no more need it in our equation, in our polynomial. So we have this as this, but the next thing we have to do is to express this function, this polynomial f of x, as a product of two factors, that is one linear and one quadratic. Now, how do we do that? We already know that x plus 2 is a factor, and x plus 2 note that x plus 2 is a factor of f of x. So to get other factors now x plus 2 is a linear factor. Since it is a linear expression, then we can call it a linear factor. And then we need to express this polynomial in terms of a linear factor as a product of a linear factor and a quadratic factor. Since we already have a linear factor, we know that the second factor that we'll be getting in this case will now be a quadratic factor. That means when we get this, we don't need to break it down further. So to get the other factor, in brackets, what do? We divide the polynomial by x plus 2. We have x cubed plus 4x squared plus 7x. I divide this by x plus 2. X in x cubed gives me x squared. X squared times everything here gives me x cubed plus 2x squared. Subtracting this, I have this minus this gives me 0. 4x squared minus 2x squared gives me 2x squared. Bring this one down, I have plus 7x. So since I have this now, I go to the next one, I say x in 2x squared, that gives me 2x. Since I've gotten it, I say 2x times everything here. So 2x times x, that gives me 2x squared. 2x times 2, that gives me 4x. What do I do next? I subtract. Subtracting this, I have 2x squared minus 2x squared, that gives me 0. 7x minus 4x, that gives me 3x. I have 3x, I can bring down the last value here. Say x in 3x, that gives me 3. I use 3 to multiply everything here. 3 times x gives me 3x. 3 times 2 gives me 6. Upon subtraction, I get 0 as my remainder. Which also in this case does not surprise me, as I know x plus 2 is a factor of this polynomial, thereby indicating that there is no remainder. That is, there is a remainder of 0. Now, what I am concerned about is the quotient. The quotient, which, as we expected, is a quadratic expression. So since it's a quadratic expression, it suits our purpose of having a quadratic factor and a linear factor. So I can now say that, therefore, f of x, which is x cubed, or let me just say f of x, has two factors, or f of x can be expressed, as a product of x plus 2 and x squared, which is the quotient here, plus 2x plus 3. In short, that is x cubed plus 4x squared plus 7x x cubed plus 4x squared plus 7x plus 6 is equals to x plus 2 times x squared plus 2x plus 3. So this is our answer in this case. And then this draws the curtain on factor theorem as far as we're concerned for now. So the next topic, the next subtopic we'll be looking at is what we call the remainder theorem. So see you in the next class, and then remember to solve more questions on this to perfect the arts of the factor theorem.